the equation. And the third theory is Pascal's principle. When the object met a force to the cushion, and the cushion will transform the same object to all other parts. So the other one will experience the same objects and in lump. So we can use the equations. And in my experience, I will change the area to discuss the area and the velocities relation. And at last is the velocity, because the question asks help you to calculate the exact velocity. And because I use the tracker to observe its track, it's a projectile motion. So we can use the equation to calculate my exact velocity. And next is my experiment device. This is a cushion, chassis, and object. And I use Excel and tracker to do my data analysis. And the first step, determine the position where the object jumps. I mark the position on the sheet with the letters, and then tie a rope on the object, pull it and have it land in the chassis. And next, we use the plastic bag to be a cushion, and we press the plastic bag with a bump. And mark the center, then secure with double side tap. And also, because I don't want any movement of the cushion, so I also secure a non-stick tap onto the cushion. And this is my photograph equipment. I press in the phone holder and fix the shooting distance each time. Next is my experiment and discussion. In the beginning, we should prepare an ideal cushion for our experiment, because cushion is a medium for energy conservation. So we want to find a cushion has a maximum thickness, so it can transform the energy more easily. So I apply a force to the cushion and measure its thickness. And based on my data, you can see after I inflate the cushion for 12 times, it has the maximum thickness. So we select the thickness inflated 12 times to do my experiment after the experiment. And this is the variable about my experiment. 1, the height at which the object falls. And 2, change in the thickness of the air cushion. 3, the cross-sectional area of the contact air cushion. In the experiment 1, I change the height at which the object falls. As you can see, the higher I drop the object, its exit velocity is larger too. And the two are a proportional relationship. So, because the position the height I drop the object, it will change the M1 and H1 layer. If the H1 is larger, it has more gravitational potential energy. So the other object has a larger velocity. And experiment 2 is the change in the thickness of the air cushion. If I drop the cushion at different pace, the change of the thickness will change too. And so, 1 and 2 is I drop the object at different position, and then I calculate the force the object applied to the cushion, and the launch force is the cushion applied to the other object.
how do you define edge? It's like the distance between the so edge is like it's like to here or to the ground.
This is the ground. Edge 1 is ground to.
Oh, the floating height.
Yes.
Okay. And also, what else can you do? Do you see the energy loss in the experiment?
Yes. So there is the energy loss.
Okay. And also, how do you define your thickness of the capsule?
I use ruler to measure it. I create the cushions at the table and the ruler behind it to measure.
Oh, okay. And also, I want to ask you, how do you define the cross-sectional area? Is it like the contact area of the dropping?
No, it's the launch object.
Launch object.
This one, the area.
So,
I didn't change this one's area. I just changed the M2's cross-sectional area.
okay. Thank you. velocity depends on the relative parameters. And the main focus is that the parameter that affect the exit velocity. And the recorder structure for observation video, they have clear demonstration and the drawing show. And for theoretical model, they use the energy conservation, the leverage, and test color. The setup, they use weights and lines. And the experimentation, they use the numbers of the pump and the initial height. And for the conclusion, they have the relationship of the parameter and the data. And the strong points and the weak points for the recursion. The strong point is that she has clear demonstration of the quantitative explanation of the phenomenon. And she has simple theoretical model for its understanding. And the weak point is that the correction of the principle is applied. And the conversion between the theory and experiment is not applied. And here's some points to be discussed on like the dropping of the weight and the dropping of the height and the theory. For theory, I try to discuss about the Pascal, the energy conservation, and the labor theory, and also the experimentation. I want to talk about the dropping angle or the dropping condition of the object. So, so first of all, I want to ask you, before I ask you about the H, how do you define the H, right? But the H, I want to ask you first, did, in your experiment, did the falling object fall to ground or fall on the carpet, and then the other object flies away? And it flies away, right? And the other object flies away. So the H should be considered from the falling height to the cushion, because it haven't fallen on the ground and it's calculated away. So in my opinion, it will be like.
This is the initial gravitational energy. So its height is ground to the height, and the H2 is it contains the cushions and shoe. So I think it's correct.
The object there hasn't fall to the ground, and she will fly away.
This
Yeah, it's fall on the carpet, so then the force, so that create force
Yes,
into the carpet, and the engine flies away.
it falls on the cushion. Yes.
So I think it will be like the distance from here to the cushion.
But this is the initial gravitational potential energy. So it should it should conclude this.
Okay, so I want to ask you the next question is that you say you have the energy between, that is the delta H here. So what in your opinion, what do you think that causes the energy decay in the experiment?
That's why air resistance, and when it contains a cushion, the cushion will. When you contain a cushion, then it's some energy goes.
Contact is like the friction.
Yes.
Oh, okay. And do you think that the H1 if the M1 gets higher, the energy loss gets bigger, or
I didn't consider that. It is not my
get higher, then it will have more and air resistance. So the delta H will get bigger.
I think air resistance is very small.
So you didn't consider that much in this history?
Yes.
Okay, I got it. And can you turn to your setup page? Oh yeah, the next one. And this next one. Yeah. So in this, I see you put on the like a tape on the. Oh yeah. So do you think that the tape will affect the motion?
Rotation.
The motion.
Of the motion. I think I use the tape just one to I put in the launch object. It won't slide up, slide down. So it won't affect.
But for the friction, do you consider friction of the?
I didn't consider the friction.
So, like, do you think there will be friction if there's a tape? If the comparison between a tape or there has not a tape, I think the friction will have some effect on it.
The cushion didn't move. So I think maybe it has a friction, but it's very small.
So next, I want to ask the dropping. Do you consider that every time you do your experiment, the dropping condition is always the same?
Oh, I use chapter to observe this check. So I do many times. The check is almost vertical. I think it's at those possible. It's very small, so we can ignore it.
Like if the whole object is like rolling.
Rolling. Oh, I kind of rolls on the object, and as I observe, rolling is very slow. You can ignore.
It can be ignored. But and like. And then I want to ask if your cushion gets bigger, just like because in your experiment your cushion is like just a small plastic bag. Yeah. So I wonder if the cushion gets bigger. Do you think that it will be like the different motion between this and?
I think if the cushion has the maximum thickness, it untransform the breath. But if I impress more than 12, its thickness will be big.
So because this is the number of the pumps every time, but it is not very it's like not very precise of the amount of the air.
Yes, I didn't, the air amount of the cushion doesn't my main focus. I use the thickness to make sure every time my cushion is almost the same.
I think you can, in my opinion, I think you can use the thickness to define that because it's more like the motion is more like talking about the energy transformation like just a dropping thing dropped on the cushion, and there are some air that's transformed to the other side and cause the second object to be calculated away. So I think that's more about the air inside.
I think its thickness is more. The object, the working object due to the cushion will be more too. So I use the thickness to mix.
Okay. So what do you think the temperature will affect the whole motion? The temperature.
I think temperature is not important factor.
It's not an important factor. Okay. Do you control your dropping position every time?
Yes.
So what is going to change your dropping position to be like
I check. You said in the experiment too. How I check the stopping position. Yes.
Yes.
Oh, yes. Okay. At first, I put an object there, and I drop the other object there. And the second time, I drop the object the different.
So you put it like so put it like so for the summarize, we talk about the calculation of the entry edge. I think the edge will be like the dropping height to the surface of the cushion, but the recorder thinks that the electron will be calculated from the dropping top to the ground. And also we talk about the energy decay rate. Energy decay. We've seen that there's energy decay in the motion, and like the friction and like the air resistance motion. And also torque. And that's my summary.
I'm the reviewer from YouTube, and now I'm going to ask the reporter, did you consider any energy loss caused by the cushion?
Yes. I say it is energy loss, but I think
Can you name any one of it?
anyone
Yes. Okay, how about you? Did you consider any energy loss in her research experience?
I think it's more like sensation and the
Okay, I want to ask the reporter, you use the Pascal principle in your theory. Did you consider the compressions of air in your equation?
you repeat again.
You use the Pascal principle, right, in your theory. Then did you consider compression of air in your equation? It's okay. It's the equation, the thickness one. You did the equations, the experiment about the thickness, right? I realized that I want to ask you, is the equation linear? condition if it is not a linear line? What is the boundary conditions of the thickness of the cushion?
I didn't consider that.
Okay. And how about you? Do you think that there will be a boundary condition of the thickness?
Thickness, yes, I think it will. And
It's okay. So how do you think the energy transforms in the cushion? Because you guys talk about it. So what do you think? How does the energy in the cushion transform?
if it's this, it's like dropping things drop on the cushion, and it's so it gets the air in the cushion to move like the.
You guys talk about the friction.
Yeah.
So did you think that the friction in her experiment affects a lot?
So I think the main cause, I think the main difference is that if the dropping surface is different, the friction will be different.
Okay, so how do you calculate the surface area that the ball has contact with the cushion?
Because I use the lines, I use this tab, so it's like
Thank you. Judges and fellow debaters, this is the reviewer from TV2, reviewing problem 16, cushion categories. So the problem statement states that they place an object on a large air cushion and drop several other objects in such a way that the first object is catapulted away. So we need to investigate how the exit velocity depends on relevant parameters. So the focuses of the reporters is to discuss the relevant parameters and investigate the phenomenon. This is a summary of the report. So the phenomenon is that they drop an object on the cushion and the other one, which is originally placed on the top of the cushion, will fly away. Their theory includes the energy conservation law and the leverage principle, Pascal principle, and the velocity. And their experiment setup include the cushion and crystals, objects, and trackers to analyze their theory. And they also change the parameters such as the cushion thickness, the height they drop of the object, and the cross-sectional area of contact of the air cushions. This is the pose of the reporters. They have their experiment set up and clearly explain their experiment progress, and clearly shows the connection between the experiment and theory. However, they have lack of the consideration of the parameters and the energy loss, and they have two less relevant parameters. For the opponents, they have it is important to clarify their theory and consider other relevant parameters that wasn't included in the reporter's report. So, however, they didn't continue to ask about the energy loss, which part, the opponent asks how to be reported the ground edge, and the report said that this is the ground to the original dropping point. And we think that it is important, and that is a good question from the opponents to ask. You need to clearly explain yourselves. And then the opponents asked, how did the energy transform? And the reporter said that it is transformed because of the gravity potential energy change to kinetic energy. And we think that the air molecules will transform the energy. And then the opponent asked, did you consider any energy loss? And did you consider frictions? And the report says that the air resistance is negligible and friction is negligible. But we think that air resistant friction force of the collision, the formation of the cushion, collision between the gas need all to be considered. And then the opponent asked what will tape under the cushion affect the experiment results. And the reporter said that it is negligible. And we think that the tape might increase the energy loss in the energy conservation equations. And then the opponent asked, do you think that the temperature affect the results? And the report says that it only has little effect on the experiment. And we think that it affects the cushion pressure and the time energy transformations. And then we asked that, do you consider the energy loss caused by the cushions? And the report says that there is energy loss, but she didn't consider it. And the opponent said that friction and heat loss may be some major factors. And we think that it is important to consider the energy loss, such as friction or something. And then we asked that, is the equation of the thickness of the cushion linear? And we think that they should consider the boundary condition because the reporter said that it is not linear and they didn't consider the boundary condition, while the opponent had no response of it. And then we asked, how did the energy transformation in the cushions? And the reporter did not answer our questions, and the opponent said that the air in the cushion. And we think also is the air molecules in cushions. And we think that, do you think that you should consider the frictions in an experiment? And we think that yes, but everyone needs more experience to prove the frictions effects on it. And the missing point is air resistance, different location of two poles high, energy loss, and boundary condition. That's my review. Thank you.
This is my summary about the experiment.
velocity.
Yes, okay.
Other questions on the group?
It's a question for viewer and opponent. So most of you has mentioned some basic physics in the theoretical analysis. So can you use 20 seconds? Most of you has mentioned there are some basic physics not included in the theoretical explanation. So can you use 20 seconds to explain us the most important basic physics, especially for the formula, experimental formulas, which are not yet taken into account. So can reviewers go first?
We think that is the friction. But the friction is difficult to be analyzed alone. So in our own experiment, we added with gas collisions and deformation of the cushion as energy loss caused by the cushions. And our results shows that the theory affects the energy loss greatly.
Any related physical formula for you to for such analysis?
It is difficult to quantify, so no.
And for the opponent?
So for the geometry polarized into the cushion, and they have their air press force like impulse force inside, so it causes energy transformation and causes a second object to fly up.
Any physical formula related to that? In addition to the formula already used, already considered by Boyens.
The boils of PV equals to AR.
Ideal gas.
Oh,
Okay, thank you.
Other questions? Question for reviewer. So you mentioned about the energy loss. Is there any parameter, measurable parameter
Measurable parameters.
for the energy loss?
I think all of it is very difficult to quantify. So in our own experiment, the material is the one that we think it can be. The
Material here, you mentioned is the material of what?
the cushion.
Like package.
Yeah, like it can be plastic or other materials can be used.
For example, the component,
about the
yeah, the
material.
energy loss.
Energy loss will caused by, like I agree with the reviewer, that the material can go past the energy loss, but also the position the object
Score for reporter. 6, 5, 4, 6, 6. The score for Holland. 6, 6, 5, 6, 5. Score for reviewer. 8, 8, 7, 8, 7.